So in this video, we're going to discuss how to use the metric system. And so this is a very important concept for a variety of topics, and the one that we're obviously discussing is chemistry, but this also plays a role in mathematics and other fields. So understanding how you convert between the metric system is extremely important. One thing that you must keep in mind is that mnemonic that I told you, which is that King Henry doesn't usually drink cold malted milk. And for us, the king represents kilo, Henry represents hecto, the drinks represents deca, usually is our units, and our units is always going to be in grams for mass, meters for length, or liters for volume. Drink is deci, cold is centi, malted is milli, and milk is micro. And as we move through our system, we actually move in units of 10. And so as we moved from our unit base to kilo, the number actually will be getting smaller. And as we move from units to our micro, the number will actually be getting larger. And so while we're using this system, there's two different ways we can apply two different systems to converting your units. So for instance, if we were doing an example where I asked you to determine to me 60 liters is equivalent to how many millimeters, for instance. And there are two different approaches to this. The first approach is to just move your decimal place over, and the number of times you move it is the amount of times that you are adding zeros. So in this example here, we would look at our mnemonic that King Henry doesn't usually drink cold malted milk to determine where we start. So right off the bat, I cannot stress enough, memorizing that mnemonic is the best strategy when you're first presented with these type of problems. As you work through them and the metric conversions become more part of your regular life in your professional career, then you probably won't need to do it as often. It'll become a lot more of a fluid movement in your head for you. But that is the first, memorizing at this point that mnemonic is the first step to success. So the first thing that we could do is we're going to just simply move the decimal place. So with our 60 liters is equal to X amount of millimeters, what we can actually do here is the first thing that we're going to look at is where does the liters component fall into our metric system mnemonic. So liters is part of our U, which is units, and again, grams, meters, or liters, it doesn't matter in terms of the unit we are using. Okay, those are all the base units. We change between them depending on what we're referring to. If we're talking about mass, we're talking about grams. If we're talking about length, we're talking about meters. If we're talking about volumes of liquids, the unit base is going to be liters. Okay, so the only thing that changes is, centigram compared to centiliter. So what is that prefix that we're actually talking about? So with our example, 60 liters. So the liters is our base unit down here, and it's then asking us to go to millimeters. So you will find where your millimeters is on your chart. If you want a highlighter, you just know where it is, that's fine. I'm just showing the highlighted for this purpose. And we will count how many places to the right we are going to go. So we're going to go 1, 2, 3 to the right. So with our example, the 60L, it's assumed that you understand that a decimal point is to the right of that zero. Okay, so if you do not see a decimal in your question, it's assumed that it follows the last digit, so it's a whole number. Okay, so we're moving 3 to the right. Okay, so we're going to go 1, 2, 3, and we're going to add the zeros in. Okay, and for 60 liters, we should have an equivalent of 60,000 millimeters. Now, for me, I need to always count backwards because sometimes I add or miss a zero when I really should not do that. So we've moved 3 to the right. If I move that decimal point 3 to the left again, to get back into our liter equivalent, I should have the 60. So we're going to go 1, 2, 3. The decimal point would be there. Yes, it would be 60. So you might not need to do that, but I definitely do. So what I just demonstrated there is our first approach, which is just moving your decimal place to the right or to the left, depending on what the question is asking. The second approach that you can use for converting your metric system is what is called dimensional analysis. Now, as you become more familiar and more confident with converting between the metric system, you'll most likely start using this method simply because it is faster. So with dimensional analysis, so again, given the question 60 liters is equal to how many millimeters, what this asks us to do is really understand just the basic concepts of the metric system conversions. And when I say basic concepts, what I'm really referring to is 1 kiloliter, just because we're working in, sorry, that should not say millimeter, it should say milliliter. I apologize for that. 1 kiloliter is equal to 1,000 liters. Okay, so with the prefix kilo, the kilo indicates to us 1,000. Okay, so what in the previous slide I was saying, as we move to the as we move from units to kilo, the number actually gets smaller. As we move from kilo back to the units, the number gets larger, and that's because the kilo to us as a name refers to it as a bigger, larger representation than liter. Okay, to be more specific, a kilo represents 1,000. So 1 kiloliter equals 1,000 liters. Okay, the same can be said from the other approach, which is we want to find out milliliters. So we're working with this M here, and we are starting with our units. Now, a lot of our scientific terms and some of the vocabulary we still use today derive from Latin. And one word specifically that focuses here is the word milli. Milli in Latin is 1,000. So in this situation, 1,000 milliliters is actually equivalent to 1 liter. So just like a centimeter, 1 centimeter, 100 centimeters is equal to 1 meter. That cent indicates to us from Latin 100. And just like we used to have a penny, a cent, 100 cents equals $1. So we start to see repetition in our language use with scientific terms, and this actually helps us out quite a lot. So in this example here with dimensional analysis, you would need to know that 1,000 milliliters is equivalent to 1 liter. And what we're actually going to do is we're going to use that as our unit fraction. So if 1 liter, this is how I usually refer to this question, is if you have 1 liter is equal to 1,000 milliliters, well, what mathematically did you do to get your 1,000? Now, because our metric system works in terms of tens, we're either multiplying by tens or dividing by tens. So the only two mathematical operations we have at our disposal here is multiplying and dividing. And so from here, we can actually only multiply 1 liter by 1,000 to actually get 1,000. So you could apply the same approach up above, which would be 60 multiplied by 1,000, which does give us 60,000 milliliters, which is the exact same answer we did just get with just moving the decimal place. Now, another opportunity another different way you can do this is actually setting up this question, these two fractions, as equal to each other, because they are. Again, the conversions should, even though we have different symbols here, we should still have equivalent units. Okay, and that's because we're converting. So what we could actually do is set up 60 liters is equivalent to an unknown amount of milliliters. And then we can multiply that by 1,000 milliliters over 1 liter. And the reason why I have switched the fraction, the second fraction, or the equivalency of 1,000 milliliters on over top of 1 liter, is because what I'm solving for is milliliters. So essentially, I want my liters, my known liters, to cancel out, and so they would be able to cancel out, leaving us with the milliliter. So essentially, we are now multiplying a numerator by a numerator and a denominator by a denominator to give us 60 multiplied by 1,000 gives us 60,000 over, well, question mark multiplied by 1 is going to give us 1 with a question mark. So the answer is that we do arrive to is that 60,000 milliliters, and that's what's called dimensional analysis. So I hope this video has helped. If there's any others that you would like to see with specific different conversions, because I just focused on liters to milliliters here, but the same principles apply for meters and grams as well. So please let me know if there's something else you would like to see that's a little bit more specific.